In this exercise, we're going to add some vectors together graphically. So we have vectors A and B given here. Vector A is this one. It has a magnitude of 12 meters. Off to the left here, this would be 180 degrees in the standard position. And we have vector B right here, which is a magnitude of 18 meters at 37 degrees in standard position. And to add these graphically, we place the tail of one vector on the head of the other, just kind of like you're walking or something. So we have, for the first one, we're going to do vector A plus vector B. So I'll start with vector A. I'll kind of move along vector A. I'll just start here at the origin, and I would move along vector A. Imagine if I was walking here or something, I would move along 12 meters to the left, basically, and then I would be at this position here, which is at the head of vector A. And then I would move, these are some magnitude, which is the distance, and then some direction, right? So I'm kind of just moving some displacement here. And I'm gonna now move vector B. So starting at the head of A, I move in the direction of B, right? So basically that's this vector here, but this isn't, it's not gonna start here at the origin, it's gonna start over here at the head of A, right? That's how I'm gonna add the two of them together. I would need to start at the head of A and then move in the magnitude and direction prescribed by vector B. So I'll just try to basically copy this one over here, and it looks something along these lines like that, right? That's vector B there. And so now I've moved along vector A, went from vector A like this, and then vector B like that, and that is my two movements there, right? So the resultant of these is just A plus B, which is effectively the same exact thing as starting here at the origin and then just moving up like that. Okay, like if I was walking here, you would never know if I walked over like this, then back like that, or if I just walked along here. It's if you were watching when I was walking, you wouldn't know. All you know is that I moved from the origin to that point. So this is the resultant vector. R, oftentimes we denote it with an R, is equal to vector A plus vector B, or this is the vector sum A plus B. Okay, and it's very important here that it's going from this point to this point, so you have to be very careful to put your arrow on there. And it's the green one that is the vector sum. It's not these other ones. This is vector A and this is vector B, right? And the resultant is these green ones. The next one we have to do is part B says to do the vector difference A minus B. Well, vector subtraction is actually just adding of a negative, right? We have vector A minus vector B is really vector A plus negative vector B, right? And so I'm still going to add them together with the head to tail method, but negative vector B is just vector B in the opposite direction, anti-parallel, so 180 degrees off, right? So vector negative B, I can just kind of sketch that one out here. If this was B right here, then negative B should go opposite direction, and so this is negative B, something like this. And these are just sketches, right? I'm just trying to get 180 degrees off from this and the same length. So that's vector negative B. So if I want to do vector A plus negative B, again, I can go out and I'd first move along A. So move along A here, and I'm at this point, and then I add on negative B like this, right? This is also vector negative B. Remember, it doesn't matter where they are in space, just how they move. And so moving along vector A, and then vector negative B, Those two together gives me my resultant vector, which is a minus b. I'm going to put this one in, I guess we'll make this blue. This is vector a minus b. Okay. By the way, it's actually maybe good to look at the commutative property of vector addition here as well. Let's actually revisit A, where we did just A plus B. What if I did B plus A instead? So what if we did, let me go back to doing this in green. What if instead we did vector B plus vector A? In other words, is vector addition commutative? Doesn't matter the order in which I add them. So remember, this green one was the resultant, A plus B. What if I do B plus A? So I will move along. Let me get rid of some of these things here. And let me first move along B. So I have like this. And then I would add A on, which is, this one off to the left, 12 meters. And I would move along here, 12 meters like that. And I would end up pretty much here. So this is also equal to this resultant, the green resultant was A plus B, but it's also equal to B plus A. I will get the same result regardless if I walk 12 meters to the left and then 18 meters up and to the right, or if I walk 18 meters up and to the right and then 12 meters left, I get the same result either way. Or I end up in the same place either way in the end. So vector addition is commutative. So I could have also said this is negative B plus A, right? That would be the same thing there. Okay, let's take a look at these other ones here. Let me just leave these resultants on. So we have, this was A plus B, and this was A minus B, the other one over here. And now for part C to this, we want the vector negative A minus B. And so the negative A minus B, this one here, is going to be, that's negative A plus negative B, right? So negative A, if A is going to the left 12 meters, then negative A is going to the right 12 meters, so that's negative A. And then negative B was the opposite of this one here. We said it was something like this, right? So negative A plus negative B looks something like this. Actually, I think it goes a little bit farther there. It's more like something more like this. This was negative A, and this is negative B. And then we have the resultant of these. It's going to start at the beginning of the first one, right? And end at the last one. So this is like that. So this vector here, this resultant vector difference here, this is negative A minus B. Which, if you look at this, it's actually, in my sketch isn't perfect here, but you look at this and you see that this negative A minus B is actually anti-parallel to A plus B, which it should be, right? Because if I throw a negative in front, if I say here negative A, let me make sure to scroll down enough here. If I have negative of A plus B, and I distribute the negative in, I get negative A minus B, right? So this would be, I have A plus B, and this would be, make it the anti-parallel, right, the negative. So this should just be A plus B in the opposite direction, and that's what negative A minus B is. If we come up here and look, this is A plus B, right, A plus B right here. and then opposite of that is negative of a plus b or negative a minus b. So anti-parallel. And we can actually look and see that we have the same thing in part D here as well, where we have b minus a. And this is actually opposite of a minus b. If you look at negative a minus b, distribute that inside, that's negative a plus b, which is b minus a, right? So this should actually be, this part D should be anti-parallel to part B. So it really should be something like this, which if you add these together, b minus a, that's b plus negative a, you get something, you go along b, then you add on negative a, and it's something like that. My sketch wasn't perfect there, but yeah, this is b minus a, which is anti-parallel to the a minus b.